Absolute value inequalities. Okay, absolute value inequalities. I said just a second ago that they turn into compound inequalities. They do, depending on which type of inequality symbol they have. Okay, hey, come on. So when you've got an absolute value inequality, maybe absolute value of, doesn't matter what's inside of there. We can put x plus 7 in there. If we put a less than symbol or a less than or equal to symbol, doesn't matter which one. Okay, just as long as it's less than some number. I'm just going to pick some random number, 17. Okay, that less than tells us this is an and problem. If it's x plus 7 is greater than or equal to some number, that greater than symbol tells us that it's an or problem. Okay? Reason being is absolute value is distance away from 0. And if distance away from 0 is less than 17.
Mr. Isbell?
Yes, ma'am?
I need Tyler Lipford to the office for just a minute.
Okay.
Thank you.
So if it's less than 17, that means it could, the distance from 0 that's less than 17 is getting closer to 0, right? And problems, the answers are in the middle. So less thans are ands because the answers are in the middle. Greater thans, if the distance from 0 is 17 or bigger, we're getting away from 0, right? So we're going away. So that's why a greater than is or, because or problems, their answers go out to the sides, right? And problems, the answers are in the middle. So that's why a less than is and a greater than is or. The saying that I've kind of held on to for the last several years is land of Gore. In the land of Gore, less thans are ands and greater thans are ors. That's the way I've remembered that for the last several years. L for land, L for less than, right? Less than and land start with the same letters. So less than, two L's, two S's and less than. And then the G for greater than. Less than is an and, greater than is an or. You've got to decide that first before you do any of the work. Okay, you got to decide, is it an and or nor problem? And you decide that when the absolute value is by itself. Up here in our little examples there, the absolute value is the only thing on the left side. The absolute value is going to be on the left side all day today. So you've got to make sure it's by itself. And we'll see some that are not by itself, and most of them will be by themselves. So we're going to look at some problems. The first thing we decide is the absolute value by itself? If it is it an or an and problem? And we'll set it. I'll show you how to set them up based on that. Okay. So let's start with example A. All right. So absolute value of x. So pretty simple one to start off with. Just a plain absolute value of x is greater than or equal to positive 6. Is the absolute value by itself? Yes. Then we look at the symbol. Is it a greater than or a less than? That's a greater than. So that tells us that this is an or problem. Okay. Doesn't affect it. Doesn't matter if that line's under, as far as whether it's an and or an or problem. Only thing it's going to change is whether you got an open circle or a closed circle on the graph. That's the only thing that it does. Good question. All right, so we set up this problem by doing two inequalities. Remember or problems yesterday, you had two inequalities with the word or between them. That's what you're going to have today. If it's greater than, it's an or problem. One of your problems is going to be x is greater than or equal to 6. It's going to be just like this, but without the absolute value marks. On the other side of the or, you're going to have x, and then you're going to flip the symbol and change the sign. So whatever's inside the absolute value is on one side. The first one is exactly the same. The second one, you flip and change the sign. Flip the symbol, change the sign. It's like it really is. We multiplied that number by a negative, so we flip the symbol. That's really what we're doing there. Okay? And there's nothing to do to get x by itself on this problem. We'll get to some that do have that and get the setup. And then you plot it on the number line. So we got to go from -6 to +6, and so we need to go a little bit past that. So I'm gonna go by twos. So I'll go -8, -6, -4, -2, 0, 2, 4, 6, 8. What kind of circle goes above the -6? Filled in or open? Filled in because it's equal to. And x is less than or equal to -6. So this is the one I'm doing first because I'm kind of just working left to right here. Which direction does that go? Less than. Yeah, goes toward the -8 there. So that way. And then above the +6, filled in or open? Lacey, please put your phone away. We're in the middle of class. Like off your desk, in your purse, somewhere besides where you're not looking at it every 2 seconds. Filled in, greater than that goes to the right. All right. Or problems, remember they're going to go in opposite directions, just like they did yesterday. And nothing different about that. It's just we've got that extra step where we got to set it up as an OR problem today. Example B. Let's do a simple one again. Absolute value of x. And then let's do less than 8. It's the absolute value by itself. Okay, so then we can decide and or. Why is it an and? Less than says that's an and problem. How did we write and problems yesterday? They were together like that one big problem. So the way this one's set up, you take whatever's inside of the absolute value, put it in the middle, and then less than 8. And then on the other side, the left-hand side of that, you put another less than symbol and put a -8. This part matches what we started with, right? You just come down to the other end and put another less than symbol and the negative, the opposite sign. Okay. And there's nothing to do to get x by itself on this one. So we need to put that on a number line. We go from -8 up to +8. So I'm going to go a little bit past -8 and a little bit past +8. So I'm going to do -10. Just going by twos here just to save myself a little bit of time. What goes above both of those? Open circles. Why open? No equal to mark. Answers are in the middle. Because it's an and problem. Okay. Absolute value of 2x is greater than 10. Or problem, because it's greater than. So we set up the first one. 2x is greater than 10. Everything's the same about it, except for it doesn't have the absolute value marks. Yeah, we'll divide both of them by 2. But we've got to set up the other one first before we forget about it. So it's an OR problem, so we need the OR, and then what's our other inequality? Yeah, 2x is less than negative. Flip the symbol, change the sign. And then solve them. Both of them you're going to divide by negative or by 2. X is greater than 5, or x is less than -5. On the number line, what if I went by 5s? That's legal. Doesn't matter which one of these you graph first. If we graph this one first, where do I start? Above the 5 with an open circle, greater than that goes to the right. Above the -5 with an open circle, less than that goes to the left. Or problems, remember, go opposite directions. Pretty easy so far. Doesn't get much harder than that. Let's go a little bit more difficult. Let's throw a little bit more stuff inside of the absolute value. Let's go 3x minus 7 is less than or equal to 16. It's going to be an and problem, yeah, because it's less than. It's an and problem. Land of Gore. Less than is and, greater than is or. So how's our setup done? How's our setup done? How's our setup done? It's less than 16. What's the other part? We don't set up a second one. We fix this one. It's an and problem. Remember, and problems are written all together in one inequality. So you put another less than and equal to, and then put a -16 down here. And problems should always be set up this way, as one big inequality. And then solve it for x. Add 7. (16 plus 7), 23. (-16 plus 7), -9. Divide. So it'll be -3 less than or equal to x less than or equal to 23 over 3. So what is 23 over 3? 7 and 2/3, 7.67, something like that. It's between 7 and 8, right? So that means I need to go to 8 or further on the positive side, and I got to get a little bit further than -3 on the negative side. So I'm going to go -4, 3, 2, -1, 0, 1, 2, 3, 4. A little bit more than that, because it's 7 and 2/3. So that's a little past halfway. So I'm put a mark there. And then what goes above each of those filled in circles? Because it's got equal to marks. And it's an and problem. The answers are in the middle. Let's spice it up a little bit here. X plus 3 in absolute value minus 2 is less than or equal to 6. Can't decide that yet. You gotta have the absolute value by itself before you decide. It may not change, but don't try to make that decision until you've gotten the absolute value by itself. Can't do that yet. You guys got to slow down. You're trying to solve before you even get it set up. You're good at solving. Got to be good at setting it up so you're solving the correct problem. So it is an and problem. It didn't change. It could, there are times when it might flip the symbol, depending on what we have to do to get the absolute value by itself. It's an and problem, so what's our setup? There you go. And then subtract 3. Negative 11 is less than or equal to x is less than or equal to 5. So on the number line, I've got to go from a negative 11 all the way up to positive 5, or a little bit past each of those. So I'm going to go negative 13, negative 11, negative 9, negative 7, negative 5, negative 3, negative 1, 1, 3, 5, 7. So I just went by 2's with the odd numbers there, just so I didn't have to put as many marks. Filled in circles. Answers are in the middle. It's an and problem. So this one, 2, absolute value of 5x minus 6 is less than 12. Is the absolute value by itself? No. Divide by 2. And or. And 5x minus 6. I think the and ones are easier, in my opinion. Is it just one problem? That should be negative 6 on that end there. I thought I wrote it, but I guess it didn't take. So what's negative 6 plus positive 6? Okay. 6 plus 6, 12. Divided by 5. 0 divided by 5 is 0. 12 divided by 5 stays 12 over 5. You think about it as a mixed number or decimal, so that when you draw it on the number line, you can get there. So I need, there's negative 1, 0, 1, 2. I did, didn't I? Thank you. 3. Heck, that's far enough. I don't need that much. 4. 0. It's an open circle. 12 over 5, where's that at? So is it a little bit past 2 or halfway past 2? How much exactly is it? I don't think it could be a quarter because the denominator's a 5. How many times does 5 go into 12? 2 times with the remainder of 2/5. 2/5 is pretty close to half, but not quite. About right there. 2.4. Open circle. So close to half, but not quite. Hands are in between. Okay. One more. I'll turn you loose. Negative 3, absolute value, 2x plus 5 minus 4 is greater than negative 10. A lot going on with this. It's about as tough as they get. That's a greater than. Got to get the absolute value by itself, so adding 4 is the right thing. So like I said, add 4, that's right. There's negative 3, absolute value, 2x plus 5 is greater than negative 6. We don't multiply by negative 3. We can never distribute across absolute values. Remember that from the other day? Yeah, and it looks like you should be able to, but don't ever do that. Don't ever distribute across absolute values. So it flips it around to a less than. So it's an and. Oh, it started out as an or, but it really wasn't an or ever. It was an and problem. Only time you ever flip your symbol, is if you multiply or divide by a negative on both sides. That's the only time you do. All right. So 2x plus 5 in the middle, 2, negative 2. Crank it out. Minus 5, minus 5. That's negative 7, less than 2x, less than negative 3. Divide everybody by 2. Fraction fun. This is not too bad because your fractions are fairly close together there. Negative 7 over 2, negative 3 over 2. Since they're both fractions, then I'm going to make my number line all fractions. So I know I got to have negative 7 over 2. So I got to have negative 8 over 2 that way. And then negative 6 over 2, negative 5 over 2, negative 4 over 2, negative 3 over 2, negative 2 over 2. And then I'm going to reduce the ones that will. 8 over 2 is 4. 6 over 2 is 3. 4 over 2 is 2. 2 over 2 is 1. Open circles. Answers between. All right, your assignment. Page 401. 3 through 20. Follow the instructions. If they say graph, graph it.